Yesterday I explained how to methods to solve linear programming problems using MATLAB. I explained conventional method and as well as using optimization toolbox. Am I correct or not? So this is the standard linear programming problem. I solved using a linprog solver and as well as optimization toolbox. Now I am going to solve nonlinear constraint optimization. Nonlinear constraint optimization. That means objective function is nonlinear. Objective function is algebraic or transcendent. Subject to nonlinear constraints less than or equal to 0. Nonlinear constraints, nonlinear inequality constraints, nonlinear equality constraints, equality linear inequalities, linear equalities, lower and upper bounds of variables. This is the standard nonlinear constraint problem, nonlinear constraint optimization problem. Here this is the nonlinear. C of x is nonlinear inequality constraints, nonlinear equality constraints, linear inequality constraints, linear equality constraints. For example, if you take a problem, suppose if you take a problem, you can get created. To minimize f of x is equal to x1 square plus x2 square. Subject to these constraints. Subject to these constraints. This is the lower bound on x1. This is the lower bound on x1. This is a linear inequality. This is non-linear inequality. Non-linear inequality. Am I correct? It is x1 square is there. Non-linear inequality. This is non-linear inequality. This is also non-linear inequality. This is also non-linear inequality. There is no non-linear equality constraint here. There is no non-linear equality constraint. All are non-linear inequality constraints. One linear inequality constraint, one upper bound on x1. Upper bound on x1. So if you want to solve this equation, if you want to solve this optimization problem, we have to create one M file for objective function. Previously, directly we entered the variables, equality constraints, linear equality constraints in the command window, and as well as optimization toolbox also. For non-linear inequalities, there is no need to create M file. For non-linear inequalities and equalities, you have to create M file. For this one, we have to create one M file. For this objective function, we have to create one M file. Okay. First, I will explain how to solve this problem. First, I create one M file and write in that write objective function that M file. Function name is object function. Variable x contains two variables. F is x1 square plus x2 square. That is this one. Next, and write M file non-linear constraints. Non-linear constraints. So I named as non-linear constraint. We can give any name for this one. Okay. Here two things are there. One is C and C equality. C is non-linear inequality constraint. C eq is non-linear equality constraints. Non-linear equality, there is no non-linear inequality constraint. So that's why I have made empty braces. Inequality constraints are there. Inequality constraints. 1, 2, 3, 4. 4 equations I entered. Minus x1 square, minus x2 square plus 1, minus x1 square, minus x2 square plus 1 is less than or equal to 0. That is first constraint. Second constraint. minus 9x1 square minus x2 square plus 9 is less than or equal to 0. Minus 9x1 square minus x2 square plus 9. That's second inequality constraint. Next constraint is minus x1 square minus x2 less than or equal to 0. Okay, minus x1 square minus x1 square minus x2 less than or equal to 0. Minus x1 square minus x2 less than or equal to 0. X1 minus x2 square less than or equal to 0. Minus x2 square plus x1. This is it. We can give semicolon, semicolon, semicolon. Because of the space constraint, I again one by one I entered one by one. We can enter first equation semicolon, second equation semicolon, third equation semicolon, fourth equation semicolon. Fourth equation no need. Fourth equation close the bracket semicolon. CEQ constraint equalities, equality constraints. Non-linear equality constraints. There is no non-linear equality constraint, so we are keeping empty. This is our. Now we are straight away. I am going to optimization toolbox. Okay. Now I will enter the. I will open this and I will open optimization toolbox. Then we get idea. The solver is fmin-con. Optim toolbox. Optim toolbox. Optim tool. So fmin-con. This is the first thing. First one is fmin-con only. So here already fmin-con is there. Constraint non-linear minimization. Take a medium scale. So objective function. Here we have to give the objective function. That for that we have to create. One empire. That is the first thing. Next, approximated by the solver. Starting point. In this one, starting point is very important. Starting point is x1 is equal to 3, x2 is equal to 1. But to mention the starting point. Here we will mention the starting point. Here, linear inequalities. What is the linear inequality here? Linear inequality. What is the linear inequality in this one? Linear inequality. Minus x1 minus x2 plus 1 less than or equal to 0. Linear inequality. Minus x1 minus x2 less than or equal to minus 1. Am I correct or not? Minus x1 minus x2 less than or equal to minus 1. Minus x1 minus x2 less than or equal to minus 1. For that, as usual, yesterday also we have given like this: minus x1 minus x2 less than or equal to minus 1. Linear inequalities. Linear equalities. No linear equality here. There is no linear equality here. Am I correct? Linear equality means like this. Previously, this is like this. 3x1 plus x2 is equal to 3. Linear equality. 4x1 plus 3x2 less greater than or equal to 6. It is linear equality. Linear inequality. x1 plus 2x2 less than or equal to 4. This is linear inequality. Here only linear inequality is there. That I entered here. Linear equalities are not there. So empty braces. Lower bound 0.5. Upper bound. There is no upper bound. Yesterday also we put empty. We can give infinite. Non-linear constraint function. We have to create empire. That the empire we have to write here. We have to mention here. Okay. Here one objective function we need. Starting point. What is the starting point here? It's starting point 3, 1. Starting point 3, 1. 3 semicolon 1. Now first we have to create one objective function, one file, m file. In that file we have to write objective function. For that I am taking one m file. Edit. Okay. Function f is equal to any name. before 28. Before 28, input is x, f is equal to x1 square plus x2 square. And that is the sum file. x1 square plus x2 square. x1 square plus x2 square. That is sum file. Say before 28 is our objective function. Before 28. That we have to mention here. At the rate of before 28. Okay. Next, nonlinear constraint equation. Nonlinear constraint functions. Nonlinear constraint functions. Another M file you have to create. Function. Here two things are two equations. One is C and another one is CEQ. Okay. Constraint equations. One is constraint, another one is constraint. Nonlinear constraint inequalities. Nonlinear constraint equalities. So before 281, and maybe yes, before 281. What are the variables? What are the inputs here? X. Am I correct? Variables. Yes. X is a variable, two equations, C and CEQ. Okay. Here I have given before two. There I mentioned. Here I mentioned non-linear constraints. This is objective function. I given another name. Okay. First, C. What is the C? C is an equations. First. This equation. First is minus x1 square minus x1 square minus x2 square minus x1 square minus x2 square plus 1. Semicolon we can give, and stay semicolon we can give, otherwise we can one by one we can write the equations. Minus 9 x1 square minus x2 square plus 9 minus x1 square minus x2 square minus x2 x1 minus x2 next CEQ outputs another CEQ empty basis. Okay. Say before 281. Say my part is not necessary. Actually, if you want to solve this, if you solve this problem, it takes at least half an hour. This non-linear constraint problems takes a lot of time. There is a standard book in this. I hope you know S.S. Rao, Sengaresh Srinivas Rao, another very famous book. B4281. Everything I filled. Okay, start. Okay. Now we have a solution. This is the objective function value 1.8. So first variable value this one, second variable value this one. First value this one, second variable value. X1 is equal to this one, X2 value this one. This is the solution. So actually, for this here some plotting functions are there. Plot functions. Like suppose if you give current point and function value and clear results and start, what will happen? This type of diagrams we have seen in the you know. Actually, that's why I will tell you all the things I have done. This is the current point values x1 and x2 value. These are the iteration value. After 6 iterations, we reach to optimization value. Okay. After 6 iterations, we got the solution. This is our solution. That is this one. 1.84, 1.84, 1.8487 like this. This one. Okay. Actually, here you see this one. F solved, so many things are F solved. I mean, F constraint. F solved. You see this one, F solved. Non-linear equation solving, mediums. So only there also we have created one M file. We have given initial point. Am I correct? There also. Did you remember that one? This is the things for F solve. F solve is non-linear solve. I will open that one. You will get a F solve. F0 also there. F0 single variable equation. What are the things there? Only will enter equation. I will open this M file. I will come back. There I didn't open optimization toolbox. There is not that much of important. We have created one there. We created one M file. Am I correct? Function by root one. We have created one M file and starting point. These two are the important things to solve non-linear equation. Here also the same. There is no need to remember this one. We direct straight away we can open Optum toolbox. Straight away we can open Optum toolbox. We have to enter this equation here and starting point. If two variables are there, we single variable non-linear equation, single variable, starting point, interval. If it is an interval, we'll mention the otherwise. If it is a starting point, we'll mention this. Only one point. I understand. Interval containing zero of the equation. If you want, let algorithm. Suppose if you want to find, if you want to give initial value, we'll put this value. Okay. Did you understand my point? Two things I told there. We can give point or interval also. Am I correct? Here. Interval or a point initial value. So straight away we can open this F0 optimum toolbox where to enter at the rate of the given function name, initial value, start. Value will come. Here we can select the current point options, current point, function count, function value, all these things we can do. Did you understand my point? Did you understand my point? Display to command window. If you want to display the answer in command window also, we can tell here of on. If you give final iteration value, iterative values. If you want to see the iterative values, we can use the iterative values. Iterative values will be displayed in the command window like this. Like that we can do. Similarly, F solve also non-linear equation. There we will give the point only, initial first value and second value. Suppose if we take next system of non-linear equations. First, we create M file and we give starting point. Am I correct or not? We create one M file for non-linear equations. Sorry, non-linear equation. Then we'll give initial value. Here also the same. Here also the same. We'll give at the rate of file name. At the rate of file name, starting point, start. We get the output. Okay, actually in MATLAB, there is one powerful window, whether I explained or not, I'm closing at present. This one I will come back again. There is one powerful window. That is this help window. Help window. Whatever you want, you can get it from this window. Suppose I want to, for example, what are things? Anything. You tell me one topic. For example, any topic you tell. You tell me one topic. Automation toolbox, anything I'm not getting. ODE 45. ODE 45, for example. These are the, you can get complete information about ODE 45. Okay. Actually, some examples also there. They will solve in different manner. Anyhow, these are the complete information we'll get about ODE 45. Okay. For example, F0. F0. F0 is there. F0 solver. F0 solver. Yeah, one cubic equation. He has taken one cubic equation. He solved the problem. So they may solve in different manner. Maybe sometimes they will use they use in different manner or different solve. They will use they solve in different manner sometimes. But the concept is same. Okay. Like this, help button will very useful button in MATLAB. Suppose one more thing, if you forget anything, help command, for example, FG. FG. Complete information will come here. Help command name. Help command name. Help, for example. Here. Help again. Age, you know, help age. Yes, help age. Eigenvalues. About eigenvalues. Age, eigenvalues and eigenvectors. So, what are the how to calculate the eigenvalues? Doc, if you want the documentation, document. Document means help button. Again, it will come to help. Help window. It will be clear. This is a different information we get from this documentation. Okay. Like this, we can use MATLAB. Okay. Now I am going to solve another problem. This complete description I have given here. Set up a written automation window. Enter a command window. Open the automation tool. Select fmincon from this fmincon. F minimum constraint. That is fmincon is to solve. Fmincon is a solver to solve non-linear constraint nonlinear optimization problems. Nonlinear optimization problems. Okay. Objective function, starting point, to data variables. Everything I explained with this. That's not. Now I am going to this problem. Now you tell me how to solve this problem. Find the value of x that minimizes f of x is equal to minus x1 minus x2 minus x3. Starting point at 10, 10, 10 and subject to the constraint. So one of the best books on optimization techniques is, I will tell you, one of the best books. Not one of the best books I am telling, not this best book, one of the best books. So this is optimization techniques. It's a very nice book. Automation. In my optimization. Automation. Techniques. This is wrong. Right. This is wrong. It's a famous book. I want to we'll open this in Amazon so that we'll get yes, this is the book. Now it is the color change. I have this book actually. The singer is Srinivas Rao. Actually, is a professor of electrical engineering in IIT Kharagpur. It's the most funny. So many things. So many. We'll underestimate some people. Engineering people cannot write. They cannot write pure mathematics books. Of course, there's applied mathematics, but has written in a pure mathematics book. His daughter is a doctorate in mathematics. Doctorate. Singer is Srinivas Rao. Another book I will show you. These are the very famous books, but most of them don't know actually. This is abstract algebra by Datta. Most of them Datta. KB Datta, NB Datta, Datta. In Datta, I will call this abstract algebra. Sorry, linear algebra. If you see this book, linear algebra. Practice and linear, yes. KB Datta, yes, this book. And this one. This also I have in my. If you see this book, he's a KB Datta. Actually, he's a professor of electrical engineering from IIT Kharagpur or Kanpur. I don't know exactly. KB Datta. If you open this book, so everything is written wonderful manner. It's very complete description about what is the necessity to study linear algebra with that big theorems. How did he prove the theorems? Basically, belongs to, he is from engineering background. It's very standard book. I love this book. Very nice. If you are interested, you buy this book. You buy this book and keep in your library. Very nice book. Okay. So don't underestimate engineering people. They are equivalent to pure mathematicians. These are very standard books. These are very standard books that people are not keeping as a reference or standard book for MSc students. Why? Because he came from engineering background. That is only the reason. Okay. This is also very nice. This is engineering people. ME people. This is a standard book. ME students. This is a standard prescribed book. Engineering optimizations for mechanical and EEE students. ME thermal students. This is standard. Now, don't underestimate engineering others. Engineering background others. Okay, now I am going to solve this book. Find the value of x that minimizes f of x minus x1. The previous problem I solved on problem, no? This problem. This is a worked example in SSR, Sengare Srinivasarao. SSR worked example. That same answer I got in the through MATLAB also. MATLAB also. This worked example in SSR. Okay, this is also SSR textbook problem. SSR textbook problem. Now find the value of x that minimizes f of x is equal to minus x1 minus x2 minus x3. Starting point at 10, 10, 10 and subject to the constraints. 0 is less than or equal to x1 plus 2x2 plus 2x3 is less than or equal to 75. Here two constraints are there. One is x1 plus 2x2 plus 2x3 less than or equal to 72. Second one is x1 plus 2x2 plus 2x3 is greater than or equal to 0. There is no non-linear constraint. Am I correct? There is no non-linear constraint. Non-linear equality constraint, inequality constraint. Okay. Linear equality. See this one. This is the standard one. No non-linear inequality. There is no non-linear equality. Only ax is less than or equal to b is there. There is no linear equality. Lower bounds are not there. Lower bound or upper bounds are not there. Okay. Now we have to enter this equation. Now you take m file. B428 f is minus x of 1 x of 2 x of 3. Save. Okay. Straight away we can open Optim toolbox. Objective function name is B428 B428 starting point is 10 semicolon 10 semicolon. Here equality empty, all are empty, everything is empty. This is empty, no need to mention. And empty lower bound, there is no lower bounds, there is no upper bounds. Empty also we can leave. Lower bounds, instead of leaving, this will keep it empty. That's better. We are not mentioning non-linear constraint. There is no non-linear constraint. Am I correct? Non-linear constraint equation. Here A and B are there. How to write these equations? This one. This is this I have to write. First, I am taking this less than or equal to 1, 2, 2. First row less than or equal to 72. X, x1, x2, x3 less than or equal to 72. Second equation. x1 plus 2x2 plus 2x3 greater than or equal to 0. That is minus x1 minus 2x2 minus 2x3 less than or equal to 0. Minus 1 minus 2 minus 2 less than or equal to 0. A x less than or equal to 0. What is this equation actually? It's Ax is less than or equal. This is the model. There is no this type of constant, there is no this type of constant, there is no this type of constant, there is no this type of constant. Only to this Ax is less than or equal to is present here. Ax is less than or equal to. Now, what is A? So we say this 1, 2, 2, 1, 2, 2, minus 1, minus 2, minus 2. Okay, minus 1, minus 2, minus 2. That is first 72 semicolon 0. Stress in matrix does not correctly solve this type of problem using medium scale. Okay. We take a medium scale, suggesting medium scale. Okay, we have the values. Okay, x1 is 24, x2 is 12, x3 is equal to 12. Okay, x1 is equal to 24, x2 is equal to 12, x3 is equal to 12. 12, 12, 24, 12, 12. This is the initial, this is the objective function value. Okay, like this here, we didn't mention any value, no? Non-linear constant, we kept empty. We can give empty braces also, not a problem. Empty braces, we'll check it. Yes, not a problem. Okay, here we should not give empty braces. This we have to keep empty. Okay. And like this, we can so this used in that method, 3 variables x1, x2, x3. Okay. Display command. Check it. You get out everything in total iterations. You get in command window. That is options we iterative I have seen. We have seen this type of output in that F0 and F7. That is options. We have used options command. We'll close this. Actually, one of the powerful windows in powerful toolboxes in MATLAB is Optim toolbox. It is actually I'm using 2007. In 2007, imagine 2020, 2020 toolbox. There are so many things came. So many things came in this Optim toolbox. They're very limited things. Quadratic programming, linear programming. Okay. So if you understand one method, automatically you can easily understand the remaining things. Okay. So I explained actually 3-4 methods. One is linprog, one is linprog, second one is fmincon, third one is f0, fourth one is fsolve. Okay. So actually first, if you want to get a mastering toolbox, first you have to uh, solve using solver. You have to take it as f0, f solve is a solver. I solved problems. We solved the problems. Then we can easily understand f solve. So here we have created a objective function somewhere. Am I correct or not? Starting point, everything we can easily understand. First, that's why I started like this. First, I started with f0, f solve. Then I started optimization toolbox, linprog with solver. I solved. Then I opened toolbox. Then after that, nonlinear constraint also is solved. Okay. So there are so many toolboxes are available in MATLAB. So many toolboxes. Latest toolboxes available in MATLAB nowadays. There are 72 toolboxes are there in latest 2020. 72, I think approximately. I'm not sure about that. 72 or 73. I'm not sure. Above 70, less than 75, in between 70 to 75. Toolboxes are available. And each toolbox is designed for a particular purpose. So if you take a where these are the toolboxes available in this 2007 version. These are the toolboxes. Aerospace toolbox, bioinformatics toolbox, communication toolbox, control system toolbox, cover fitting toolbox. This we open cover fitting toolbox, cover fitting like this, fuzzy logic toolbox, somewhere to optimization toolbox. Where is optimization toolbox? Optimization toolbox, neural network toolbox, partial differential equation toolbox. Like this in the 2007, these many toolboxes are available. How many? So 1, 2, 3, look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 30, 31. Around 60 toolboxes, above 60. Am I correct? Statistics toolbox is very nice toolbox. It's a very wonderful toolbox. This one, statistics. We can solve ANOVA problems. So simple ANOVA problems, all statistics problems easy. Now there is a software, SPSS software. SPSS software is especially for statistics toolbox. So this is also very powerful toolbox. SPSS, equal, not more than SPSS, statistics toolbox. So if you are interested, open the toolbox and open take help button and try to solve the problems. Okay? Definitely, and you have to practice. That is one other thing. Then that practice will help you a lot, no doubt. This is about uh, optimization toolbox. If you have any problems, if you have any optimization problem, give it to me. I will solve. Otherwise, I will start graph theory concepts. Graph theory. How many of you are aware about graph theory? Graph theory. Graph theory. Graph theory. Valli. Okay. Next. Only one. Next. Graph theory. Okay. I will open graph theory. Graph theory. I will start with the graph theory concepts. Where is graph theory? Just 1 second. I will open one PPT. So I will give a brief introduction about graph theory. Then I will move to MATLAB. So according to discrete mathematics, a graph G consists of a pair V of G and E of G, where V of G is the set of vertices and E of G is the set of edges. The cardinalities of V of G and E of G are often called order and size of the graph. And each edge of E of G connects two vertices from E of G, called the endpoints, or called the ends or endpoints of the edge. Okay, this is the number of edges that a vertex V is incident to a G is called degree of a vertex. For example, if you take a graph, this one, there are 6 vertices of there. 1, 2, 3, 4, 5, 6. These are called vertices. These are edges. These are called edges. The degree of the vertex V6 is 2. The number of edges incident to this vertex is called degree. Degree of this vertex is 2. The degree of this vertex is also 2. The degree of this vertex is also 2. Okay. That is the definition of a degree of. The number of edges that a vertex V is incident to in G is called degree of V, and it is denoted by D of. The adjacency matrix of E. The adjacency matrix of E. The adjacency matrix E of G is defined as E of I comma J is equal to 1 if VA is adjacent to, if VA and V are adjacent, otherwise 0. So like this, we write a matrix. That matrix is called adjacency matrix. The adjacency matrix of order n by n. 6 vertices are there. So 6 by 6 vertices. The first row, V1. So V1 is not adjacent to V1. There is no self loop here. So it is 0. V1 is adjacent to V2. V1 is adjacent to V2. So we take it as 1. V1 is not adjacent to V6. There is no direct edge from V1 to V3. So we take 0. V1 to V4, 0. By because there is no edge, V1 to V4. V1 to V5, there is no edge, 0. V1 to V6, there is an edge. The definition is here, this one like this. Ij, I through jth column element is 1 if Va is adjacent to Vj. First row, second column is 1. Here, first row, second column element is 1 because there is an edge from 1 to 2. First row, sixth column element is 1 because there is an edge from V1 to V6. There is an edge from V1 to V6. One second. Okay, like this. Suppose V1 to V2 to V. This is 2 1 element. 2 1 element. There is an edge from 2 to 1. So 1. This is 2 to 3. There is an edge from 2 to 3. V2 to V3. There is an edge from V2 to V3. Like this. Like this. If you write a matrix, this matrix is called adjacency matrix. Adjacency matrix. So using this adjacency matrix, we can create, using adjacency matrix we can write graphs in MATLAB. We can draw graphs in MATLAB. So I won't suggest MATLAB to draw a diagram. There are so many softwares are available to need diagrams. For example, I will tell you, there is a GeoGebra software. GeoGebra software is there. I won't suggest MATLAB to draw this type of diagrams. There are some small softwares are available. For example, this is the software. So we can, using this diagram, we can easily draw the graphs. So, but basically we use MATLAB is not designed to draw the diagrams, but we have to create graphs to get to find shortest between vertices, minimum spanning trees, like that. So I will show some diagrams. All these diagrams I drawn using this, for example, not this one, and for example, this one. This I have drawn using GeoGebra software. It is better to take GeoGebra if you want to draw this type of diagrams. You don't use MATLAB. Okay, you depend on another software. That is so many softwares are available. One among them is GeoGebra software to draw the diagrams like this. For example, some diagrams like this diagrams. You can easily draw diagrams using this type of softwares. Okay, like this. But the thing is, if you want to get some information from MATLAB, some information about the graph with aided with MATLAB, we have to create an object that is a graph. But if you want to plot that graph in your paper, journal paper, I won't suggest MATLAB. There are another softwares are there. Graph-T one, another software. Graph-T. Graph-T software is also available. I will show this Graph-T. Graph-T. This is a software. These are very nice software to draw the diagrams. Okay, this is free download. You can easily download. This is GeoGebra also free. Okay, if you download this software, we can easily draw the diagrams. I think I have Graph-T software. No, I don't have. Okay. Okay. So tomorrow I will start. I will explain how to draw the diagrams using MATLAB. Then I will explain these things. Creating directed and non-directed graphs, and shortest path between vertices and minimum spanning tree. I hope you know these concepts. Otherwise, you refer the textbook before coming to the class. So straight away, I'll start the topic. It takes It is very difficult to explain theory and as well as application. And straight away, I will explain. I will give a brief introduction about minimum spanning tree. I will try to find. I will try. I find the minimum spanning tree using MATLAB. Similarly, shortest between vertices. Okay, shortest path between vertices. Shortest distance, that is. Okay, so minimum spanning tree is very powerful concept. I hope you know everything. I know about this concept, minimum spanning tree. Tomorrow I will show some minimum spanning tree PPTs which I have. I have some minimum spanning tree. My own presentations are there. I will explain. Tomorrow I will explain these concepts. This is a very nice concept, minimum spanning tree concept. See these diagrams done using some other software. Okay. This is a minimum spanning tree. You know, I think if you minimum spanning tree, this is a minimum spanning tree of this network. I'll explain. I give a brief introduction about minimum spanning tree. Okay. This is one of my presentations in college. It takes actually this entire class. I will spend 3 hours to explain all these concepts. But I will brief introduction I will give to this minimum spanning tree. Finally, I will tell how to find out the minimum spanning tree using MATLAB. All these things I cannot explain in this class because tomorrow I will explain all these concepts. I will spend more time on this. Otherwise, tomorrow, day after tomorrow, I will if anything pending, I will explain day after tomorrow. Then I will go to LaTeX. So all my presentations are prepared in LaTeX. So this presentation I prepared in LaTeX. So this is the beauty. You cannot insert ordinary PPTs like these symbols, like x1 square plus x2. If you want to insert, I showed one diagram. It is very difficult to insert this type of diagram in this spanning tree. See this one. This is PPT prepared in LaTeX. See this one. It is very difficult to insert like this diagrams in ordinary PPT, Microsoft PPT. This type of diagrams, it is very difficult to create. It is very difficult in ordinary PPT. In ordinary PPT, we cannot prepare like this. Here, it is very difficult to create a space here. It is very difficult to create a space here. Okay. Not only PPT. If you want to present, if you want to send a paper to standard journal, you have to prepare in a LaTeX document only. Am I correct or not? You want to, the standard journals are there, like Scopus, Web of Science, Sci-indexed journals. They are asking LaTeX format only, not ordinary Word document or PDF document. So they ask in LaTeX document only. Okay. LaTeX. So these papers, I am telling the importance of this paper. For example, if you take this paper, this paper is written in LaTeX. This paper is written in LaTeX. It is very difficult to insert this type of symbols in ordinary typing. Ordinary we cannot insert this type of symbols. Okay. So this paper is written in LaTeX. LaTeX document will be like this. Everything you have to write, give a command, but difficult, but it is very useful. Nowadays, students are earning 5,000 to 6,000 part-time. Suppose if you want to prepare this, suppose I am telling in Chennai, so all Anna University students are earning money through this LaTeX only. So they are charging 2,000 rupees to prepare a LaTeX document, to type in LaTeX paper in LaTeX. 2,000, 3,000, 4,000, depending upon the pages. So if you become an expert in this area in LaTeX, you can earn money. That is not only earning money. So your document will get a beautiful form. Okay. It's look nice, very nice. For example, I will show you another document. For example, if you see this, so it's not over, I think. And minimize, I will minimize it. I hope you understand the difference. You see the ordinary paper and this latex paper. Everything you see the beauty of the alignment. The alignment will come very nicely. So I am motivating to towards the latex class actually. Okay. You see this alignment. And automatically theorem will be generated. Everything will be generated automatically. Numbering will be generated automatically. Okay. It's very difficult to create this type of symbols using ordinary Microsoft Word. Am I correct or not? It's getting curly braces, references. Good thing. So day after tomorrow, I will start LaTeX. It will be very useful to you, no doubt, like MATLAB. Okay. Tomorrow I will close the graph theory and I will start with LaTeX. Okay. With this I am closing today's class. Tomorrow I will start graph theory concepts.